put each and every person in that data set and try to find anomalies in the data set. So idea here is that you have huge amount of data that exists from the past successes, past people whom the bank has loaned, the return rate, like how many times that loan became bad when the people did not return the money. They use that as a indicator and try to find out, does this person most likely is going to be a person who will not return the loan, or is going to be more likely to be a person who will return the loan. So that would become kind of a fraud model for a bank. So all insurance companies, all banking institutions, etc., this is how they'll monitor fraud. So I can, most of the time what they do, this is a terminology of predictive analytics, big data predictive analytics. And what they do is they collect all the data from the historical transactions that a bank has done, like all the people who have taken loans, like what their industry, etc., etc. These are the different type of features that these people provided. And what was the rate of return, like were they able to return back the money to the banking institution or not? They will have all this historical data, let's say Bank of America, they have data for the last 100 years of all the people who have taken loans from them, what were their parameters, demographic, age, sex, things like that, as well as like what companies they invested in, how much time they took the loan for, etc., etc. And they will also have fraudsters, like people who swindle money from the banking institution, did not return back, and they'll come up with a model, fraud model. So models can be based on multiple machine learning algorithms. Some may be kind of random forest models or decision tree models and things along those lines, and they will build these models to classify a fraudster against non-fraudster. And they will build a model, and they will just pump in my ID to the system, and the system will classify me as a, looks like there are 80% chances this guy is a fraudster. And then banks can take an action whether to give him the loan or not give him the loan. That's the way a fraud management system would work. And this could be applied in banking industry, insurance industry, telecom fraud, stock market fraud, any kind of fraud agency. The real thing here is most of the cases would be good. Fraud would be like less than 1% of the cases. And the idea here is to find that between all this huge amount of data, how do you find that less than 1% of the data? That's the fraud model. Anybody needs any other example of any thing like search quality, retail churn? Anyone? None? Search quality? Okay, cool. So as we know, Google is a market leader in search, followed by Yahoo and now Microsoft. So search has been always a very, very big problem in computer science. And the main focus of search is that whenever you type something, the keyword that you put in search, you want to be able to get a result that matches your intent. So by the keyword that you type in the search bar, you want the response that comes across should be matching the intent. So that's known as search quality. So if I type Apple, are you talking about Apple as in company or Apple as in fruit? How do you tell that? Like I only write Apple in the search bar. How does the engine know, I'm talking about the Apple as in company or Apple as in fruit? So if the engine is smart enough, they would take consideration of my past search results, who the person is. They will take consideration of from where the request is coming. Am I searching it on my mobile phone or from my tablet or my laptop? What kind of past searches I have done? Who are my friends? They'll use social media data. They'll use my past history. They'll see what are the things that I have done before doing this search, just recently, real-time analytics. And based upon that, they'll make an educated guess. Is he more likely talking about Apple or Apple as in a company, or he's more likely to talk about Apple as in fruit? And that way they'll rank all the, so it's not only about the content, like wherever the Apple keyword comes into the content of the page, but also based upon they'll rank them. Okay, looks like there is a higher probability this person is talking about Apple as a company. And those search result pages will be ranked much higher than Apple as in fruit. So it's a kind of a probabilistic estimate and they rank it. So that would be search quality. So that's the way you rank the search results. Try to bring in the results that are most likely to be clicked by a user will be of a higher quality than the search results which will be of lower quality which people are not likely to click. And any same way advertising also works the same way. Search advertising, you want to bump in those ads which are higher probability of clicking than those ads which may never be clicked. So that's how the search quality and search advertising works. So moving on to next. So I like to draw your attention to the most recent event that happened recently. So unfortunately, there was a hurricane, I think 1 or 2, like last year in New York, I forgot the name, Sandy, I think, right? Sandy was a hurricane that happened. And real-time data analytics was used to track the movement of hurricane and really track and see what the path of the hurricane is in real-time data analytics. So you have huge amount of data like environmental data, what the pressure is, what the temperature regions are, where the cloud formations is, where the population is most, which might be impacted most. So all these different parameters were used to detect the path of the hurricane. So as you can see, so there is dynamically updating the path of it based upon the real-time data that we access. So that was used. So this is one of the most recent applications I got of. So none of these slides have been made by me. I just did research. It is known as research, right? If you get it from the internet, just put it all together. That's how you call it as research. So that's what I did. So, and I've given credits to all the people. Like my last slide says that, okay, I've got these slides from these different sources. So I'm not taking credit. I'm just speaking. Moving on next. So as one of my friends in the audience said already, again, this is a very beautiful slide. See, very good animation, how it is moving and values being creating all the way up. So I like to define volume here first. So as many of the people here already understand, volume is about, now we are talking about petabytes, zettabytes of data. Not that this is anything new. Even in earlier days, you used to have that amount of data. But that was not kind of stored like in a consolidated place. People didn't have access to, let's say, cloud-based systems or cloud-based storage in data centers, etc. Now we have access to it. The reason why we care about so much data right now, because the cost, the investment that you need to do to analyze this huge amount of data has driven down very, very significantly. Like if you were talking 10 years back, it was very, very costly to analyze huge amount of data. But as the technology has improved due to cloud services and a lot of open source tools, the cost to analyze huge amount of data sets has gone down significantly. And hence, it makes sense to analyze huge amount of data. So the volume, now we are talking about petabytes and zettabytes. In earlier days, like 10 to 15 years back, nobody will damn care about the social media data. Who cares? It's an intangible value. It may not be directly be associated to create value. But now people can do social media analytics because the cost has gone down so much to analyze that data. So earlier people will only talk about transactional data, right? On the databases, how many credit card transactions has happened and things along those lines. Now, if you club the data with social media data, so suppose, let me give an example. So there was a recent case study, I think it was done in MIT, I'm not sure, maybe some Ivy League school. The study was, can the social media data predict the movement of stock? So that was the question people were asking. And what they did was a very simple case study. They went to Twitter and started seeing the Twitter hashtag for a particular stock. And if they did a sentiment